Victor, thank you so much for taking the time to visit with me. This is a really important conversation, and we've dove into deuterium quite a bit, but water's a huge story. But like some previous guests that we've had, like Stephanie Sneff, Laszlo Boros, we had Gabor on yesterday. Petra Davlar is one of my absolute best friends. We do all kinds of stuff together. So deuterium is something that we are very much familiar with, and we utilize. We believe in what it's doing, and so with that, it's something that we utilize in my son. So he was diagnosed stage 4 cancer in 2019. He's doing great now, but it's something that we stay on. And you have one of the solutions, right, that we're talked about, I guess more than anything, with Litewater. And so I wanted to take the time to discuss what y'all do, why you do it, why is it expensive, why does this matter, like all of the things that you've probably said many times, but I think it's worth rehashing out. So Victor, thank you for joining me, brother.
Well, thanks for having me. Appreciate it.
So, do you care to give us that brief overview on how you even came to realize water matters and deuterium was even a thing?
Well, I've been a water researcher as far as I can remember. So, going back to my teenage years when I realized that not all water is the same. So, I had a profound experience. I think I don't know, like 16 or 17. Up until that point, just drank water out of the tap, and then somebody gave me some bottled glacial spring water. It's called Canadian Music. I don't think it's around anymore, but it was in a triangle bottle. It was cool, and I drank it. I go, wait a second, why does this taste different than that water? I thought water is water, and that set off a basically a multi-decade, lifelong quest, mission of inquiry to understand water. And it's a great subject because it's you can't hold it; it slips through your fingers. So there's so much to learn, right? This is almost there's no end to knowledge, but we understand the basics now, and so many people have paved the way in that understanding, paving science and just practical wisdom of what it takes to be healthy and how water is so, why it's so important, why we really have to take a closer look at the water that we make in our bodies, how that relates to water that we consume, where we consume it from. So this whole water conversation is really it's really new. It's really a second half of the 20th century that people started looking into water filtration as a solution for illness, for preventative disease. So the deuterium thing is something that I found out about in 2004. So as soon as I read what I read, I realized this was something that was overlooked for a long time in science, because it was something that was known about, discovered really in the late 50s, published in 1961, and then in Soviet Union, and then 66 in Nature in the US. People knew about this deuterium problem, even going back all the way to the 30s when they realized that hydrogen had more than one isotope. So, but to be brief, I'll say that this is something I wanted for myself, right? And there was no way to get it. So it was like really a 15 plus year mission to get it for myself, and in the process create a product that everybody can have.
I love it. Yeah, just kind of the wake up for me was actually Jack Cruz. The first time I talked to Jack, I was like, "What do I do for my son?" And he's like, "Well, you get a tan on his back and you keep him off screens." And I'm like, I don't even know what that means, right? Like, what are you talking about? What does melanin have to do with any tan? And so, but
Sure.
that plays into all of this. And so Jack's who introduced me to deuterium, and then understanding the depletion process, and that there are differences across the globe. So where we are is I think everybody in the health space has at least heard of Mountain Valley water, right? Like the green bottles that everywhere, and it's touted as a health food or a health water. So can you go into a little bit on the distribution of deuterium across the globe? So us in Arkansas, where Mountain Valley is, would have maybe a different content than a glacier water that you had from the early Canadian one. So
Sure,
what's
it's
that about?
fairly easy subject and explanation. All ocean water is 155.76 about, and of deuterium parts per million. Right? So that makes all drinking water about 150, 95% of all drinking water. And then in certain places, it goes down, right? In North America, in the continental United States, I think it goes down as low as 135 in some places. And then in Antarctica, which is a land locked in time from millions of years ago, 50 to 80, 100 million years ago, that water there is the lowest on the planet, 89 parts per million in the snow there. So there's this fluctuation, but most people are in that 145 to 150 ppm range from their local water. And that really depends on how far you are away from the hydrological cycle of the ocean, because the ocean is always carrying that deuterium-rich water. And it depends on the elevation as well and the latitude. And these are known scientific principles about hydrology. And so it's how fast water evaporates and condenses down determines how it fractionates and how much deuterium is exchanged. And so certainly people that live in places like mountainous areas away from the oceans, they're going to have water that is lower in deuterium. I'll give you one example. If you were to take Los Angeles or any of these coastal cities, San Diego, San Francisco, you're going to get water out of the tap that's 150 parts per million, which is normal. And then if you go to Boulder, which is like middle of the country, and you're on the eastern slope, which is even further away from the hydrological cycle of the ocean, and you're already high up in the mountains or a mile up or more, you're going to have water that's 138 ppm about, right? So over time, that delta of, what is that, 5-6%, something like that, that delta over time is going to be very significant. So if you have twins and one settles in LA drinking 150 ppm water for 30 years and the other one settles somewhere on the eastern slopes of the Rockies and drinks deuterium-depleted water, over time, you're going to see a completely they're going to be metabolically different. Even though genetically they're the same, metabolically they're going to be different because of the conservation of energy over time as you age, and basically saving yourself from damage, but also increasing your ability to produce energy. So everything is an energy game, and everything becomes energy management, right? Your body managing the energy that it thinks it's getting, or that it has, whether it's running at a surplus or a deficit of energy. So, and then you look at how energy is made, and a significant one is the metabolic pathway, the mitochondria. And so then in 2007, Dr. Abdullah Olgun in Turkey discovered exactly how the mitochondria gets damaged by the deuteron, by deuterium. It's a purely mechanical thing that happens. It's terrible because it's continuous, and it's a mechanical thing that causes these motors that make ATP energy to break and stutter. And this is a deuterium problem because it's too heavy to fit in that motor. Now, that's one energy pathway. And then you mentioned melanin, another energy pathway that is little discussed. It's kind of the modern science is still getting to that foundation, understanding how melanin works, but a good number of scientists already do. So you have these different energy pathways in your body, ways to create and conserve energy. And this is where the reduction of deuterium comes in.
Yeah, there's a couple different directions I want to go there. Let's start with photosynthesis. We're currently, and this is because of Jack. The last time he said, "Hey, one thing I want you to do is with your kids, get you some plants, and then try the difference between using deuterium-depleted water and distilled water, tap water, whatever, and have the same soil, same light, and see how that plays out." And with that, so far where we are is we got like 8 basil plants, and we actually use some of them with like the analema wand, right? Like I just wanted to see all the different types of waters being used on these same plants. And right now, without question, the deuterium-depleted watered basil plants are much darker green. They're a lot more structurally sound, whereas some of the like distilled are very spindly. They're a lighter color yellow. They're longer but thinner, right? And so go into a little bit of the differences on that. Why would the basil plants be so different based on the only variable being deuterium water?
You're repeating an experiment that was first done, I think, in the late 50s with tobacco plants, and they saw that with DDW, they just were like two times bigger, grew faster. I think what's happening here is it's deuterium as an intervention, or the reduction of deuterium depletion, is really about oxygen utilization. Okay, and it's a gas exchange that continuously happens, carbon dioxide and oxygen, right? So the ability to utilize oxygen is just improved. So you're in the basal, you're seeing more verdant foliage because there's a more optimized exchange of oxygen and carbon dioxide. You're getting basically, the plant is able to get more nutrition because metabolically it's stronger, right? So everything downstream of that, right? You fix an upstream problem, and everything downstream of that benefits. Whether if you fix a downstream problem, nothing upstream benefits. So you're really working on this is an upstream solution, and so yeah, it's utilizing it's basically utilizing biology better because it has less resistance in its ability to create energy.
So, to my understanding, when we're talking about photosynthesis or even kind of that melanin piece, the charge separation of hydrogen within water is 12.06 volts. Do you have any idea, if first of all, if that's accurate, or if you know what that charge separation of deuterium is?
It's very there's so Here's the misnomer. We don't remove deuterium. We remove a molecule that's HDO, that has deuterium in it. So you have water. Water, as we know it, is H2O. But a little bit of water, like if you have a liter of water, most of it will be H2O. But then there's going to be probably about 6 drops, if you were to be as accurate as possible. 6 drops will be not H2O, but HDO or HOD, depending on how you want to name it. And the difference between the HDO and the H2O is very minute. That's why it's so difficult to create deuterium-depleted water, because you're trying to separate one type of water from another type of water. So, but back to the photosynthesis piece. I've been studying this for a couple decades, and I follow the work of a number of people. Some have passed on, but there's a scientist, doctor, researcher that by the name of Solis Herrera, okay, Arturo Solis Herrera, and he wrote a book called Human Photosynthesis. You have it, okay, yeah, and I love that book. And Dr. Herrera was going to speak at our conference. We just postponed it, but so I think he was on to something. There was Panos Pappas was on to something. He's no longer with us, I believe. So there are people that have touched on this melanin piece for a long time, and it just ignored. And when I was talking to talking to Dr. Herrera, I said, just give me the elevator pitch, and give me, if I'm just here, I'm a biochemist, I'm riding an elevator with you, you're going to shatter my entire worldview and foundation of science. Give it to me in a 20-second pitch. And he simply asked, how does the nucleus of the cell get energy? And I go, wow, there it is. Because standard chemistry and biochemistry will tell you what they'll tell you. I mean, I highly question, so do many people, because there's no mitochondria inside the nucleus. So the nucleus must get its energy from somewhere. And if it has to get its energy from outside of the nucleus, then there's something that has to happen to get through that semipermeable membrane, and that you need energy for that. So that doesn't solve the question. It doesn't answer the question. The only thing that answers the question is that in the nucleus of the cell, the energy is made some other way, and that energy is melanin. And the phenomenal thing is with melanin is that you look at the mitochondria, like cytochrome C, and you see that you can see that it photomodulates a specific frequency or specific wavelengths of light, and it changes that from photonic energy basically to chemical energy. And outside that spectrum, it's just heat, right? You're just heating your tissue. But like we know that 660 nanometers and 830 nanometers, right? They affect the viscosity of the metabolic water. Right? and those are specific, right? Like the mitochondria. That's it. These are the frequencies. these are the wavelengths that work, and that's it. The amazing thing about melanin is it's a sink for anything, right? Any visible spectrum of frequency, any X-ray. I mean, anything. Ultraviolet light, infrared light. It'll use anything as energy, right? So basically, it'll take the vacuum of space as an energy source, right? So that's incredible because now you have this energy source. And so what is it doing with this energy source? Well, it's reducing hydrogen to water, and it's basically breaking water, cracking water into hydrogen and oxygen, and then combining hydrogen and oxygen, reducing the hydrogen to water. And in that process, energy is created, right? In that energy process, there's a in that react, like if you were in a lab and you put 2 parts hydrogen and oxygen together, you get a drop of water, but you also get a boom, right? You also get some kinetic energy coming off of that. So, and this is the argument that people in this space are making and saying, look at energy, look at the energy that is made by melanin, and how much more efficient and how much easier it is to make than this mitochondrial energy that has to break down all food that we eat to create essentially to break it down to hydrogen. And so I think in the future we're going to have this more. It's going to be a more discussion about a secondary or maybe even a primary energy production pathway that we've overlooked, which is melanin. And the people that are doing work on this, I think they are paving the way, and they're heroes, really, because it's going to shake the foundation of chemistry to its core. And certainly there's a lot of people that are going to challenge it. But if you read that book, it's like, how do you deny it?
I don't know. To me, this seems like the photoelectric effect, right? This is light, and we cleave essentially electrons. Is that an accurate oversimplification?
I don't think it's inaccurate. I think we are energy sponges, right? We're sponges for everything, and that's what I'm saying is melanin. It'll take any wavelength of light, anything as fuel. So it's really it's impossible to not power melanin. Where
Yeah.
it's possible to not power mitochondria, it's almost impossible to not power melanin, because everything becomes an energy source for it to crack water and reform water. And the reason Dr. Herrera got on this theory is because he's an ophthalmologist, and he started seeing things that he couldn't explain in eye surgery and working with people's eyes.
Which when you start looking at anatomy and physiology of like the retina, like utilizing a Warburg metabolism, right? Like this is exactly what doesn't explain it.
Doesn't explain it, right?
It doesn't explain it, right? So I don't want to get too far off base, but I think the light piece and the melon piece are so absolutely fascinating. We recently, Petra had found where a study talked about like melanin having like an 80 times more affinity for blue light, right? And actually can be degraded and broken down into like dopamine. This is where we get like that addiction to blue light, these screens and everything. So um, I think that's a big deal. So you have any thoughts on that before we go back to the deuterium?
These technological innovations are exceeding our ability to evolve to match them, right? I think some adapt better than others, but all wavelengths are essentially an autonomic trigger, right? Blue makes you think you're in the height of day, you're in midday. So we love tricking ourselves, tricking our brains, tricking our bodies, and we just have to do it intelligently, and there is a certain amount of adaptation that has to occur, and this is, I think, one of the reasons we are discovering things like deuterium depleted water and getting to understand some of these mechanisms that will make us more resilient as we step into this brave new world of a technological future. We're going to have to deal with it. And so to be more resilient, to stay ahead of the pollution, I think it's better than to isolate yourself away from it, because at some point
Yeah.
it's not going to work.
And the cancer correlation is massive. And
The
Gavilar's
cancer,
latest.
the interesting. When I was a teenager, there was this. I grew up in Chicago. There was this old mobster, and he told me a story that he got diagnosed with cancer. He never went to a doctor, and his kids were pressuring him. He had a lot of money. So he went to the doctor, and the doctor said, you have fourth stage, you have end stage cancer. I forgot, I was 30 years ago, something like that. So I forgot what cancer he said he had. But he said, doctor, we have to get you in the hospital right away. You have to start treatment. You've got X number amount of months to live. You got cancer. So the guy goes, I never been to a doctor before. Now he's going to tell me I'm going to die. All he means is I need to get some sun. So this guy, he stops, doing his mob thing in Chicago, goes down to Uruguay, and he basically just like lives in the sun for 6 months, like a lawn chair and a beach and the sun. He comes back, dark, dark, rich tan, cancer free, probably lived another 30 years. And he just said, I need some sun. And it's true. Like I've never seen anybody that's like a sun bunny, have some kind of a cancer issue. Now there are people that are deathly afraid of melanoma, being in the sun, but that's because they're not taking care of internally what needs to happen. So and plus the sunscreen and all that. So if your body can be at war with itself. It can be at war with its surroundings, and but that's not, sun exposure is not the cause of melanoma. So I thought that I share that because that story has stayed with me my whole life. How this guy just told me, like, I went and got some sun and now I'm cancer free. Never forget those doctors.
Yeah, that's incredible. So what do you think? What do you think the reason for him having that perception is? Is that kind of ancestrally? Is
Yeah,
this?
with him it was a cultural thing.
Yeah.
Yeah,
So I'm assuming maybe Italian.
yeah, it was it's Sicilian. Yeah,
I,
yeah.
I, but like that is to me, I follow Jack very, very closely. To me, that's what Jack would say. Go get closer to the equator and get in the sun.
That's a I mean, folk medicine. That's what folk medicine prescribes. You got a problem with you. You look a little pale. Go. I had another friend in Palm Springs. He had end stage pancreatic cancer. I mean, he all he did was just a few things, and one of those things was just sun exposure for 8 hours a day to the point where he was just burning. But it did it. It did it. It's just if the body's receptive, it's another vector of accumulation of energy. Yeah, that's all it is. I mean, I remember first time I did a extended fast, for 7 days. I was tired, and then I got sun exposure. Next thing, I'm running on the beach, and I go, how's this possible? I haven't eaten anything for 7 days, and here I'm full energy. And the only difference was I laid in the sun and stared at it. And then I started, years later, I practiced sun gazing, where you're just staring at the sun when the UV index is ideally below 2 or less. And we evolved with that solar thermonuclear disk in the sky, and so everything is dependent on it in our cellular biology, and we've adapted ways to we are masters of finding the path of least resistance. We want things easy as we can get them, and nature is happy to concede if you're intelligent enough.
Yeah, no, I love that. And so water is that battery that we utilize light too. And so, like that to me is so fascinating, and why water is so important. And heavy water is going to have a different physics than metabolic water or deuterium depleted water. So,
At the end of the day, it's kinetics. Right? At the end of the day, it's simply gravity. Right? One's heavier, one's lighter. We all like the feeling of being light. The only where I don't know of an instance where you want to feel heavier or slower. I think we all
yeah,
want to be lighter and faster.
E equals MC squared, right? Like it's pretty simple as you just keep diving into it. So, well, let's go into a little bit of the way you view consuming water, right? Because on one hand, I think it's important to discuss the perception around quantity, right? You've got people walking around with a gallon of water chugging it, and that's it's terrifying, right? So, like, let's go into why that is a really bad idea. And I think so much of it is because people don't even realize that we create water from mitochondria. But
All
let's
yeah,
go into that first.
all water, all water we drink is bulk water, as some people call it. Bulk water is just it needs to be refined, right?
Yeah.
And in fact, it'll never be refined to the standards of the human body, because the human body makes its own water. It doesn't use any of the water that we drink for its metabolic process for ATP production, right? Those innermost confined spaces in the mitochondria, they prefer to make their own water because it doesn't trust anything that comes from the outside. And we can we can observe and ponder that for a while, and what we come out with is that the body requires things in a highly pure state, and that whatever we put in our body is completely just broken down into its building blocks and reformed how it's needed, right? Except for the things that have the word essential in them, where our bodies can't reconfigure it and make it into what it needs. So our bodies make metabolic water, and this water is deuterium depleted. It's 60 to 70% deuterium depleted. So light water is the closest thing to metabolic water on the purity level. So water is a medium that exchanges. Basically, it's a great medium for a lot of things, but one of those things is information, right? It's a conductor. It's a conductor of information. You could call it electrons, photons, but we can call it information. And so it's like a hard disk. How quick can you access it depends on how defragged it is, right? On the fractality, on the coherence that the water in your body has, and the resistance that it's coming up against, or the resistance that anything is coming up against, because we live in an entropic universe. At least we think so, right? Where everything winds down eventually. So we're constantly dealing with not only the need for energy, but also dealing with the fact that our coil is slowly unraveling, that our ability to accumulate energy as we age is slowly decreasing. So we constantly deal with this, and this has to do with the coherence of the water. Our bodies are 99.8% water by molecular weight, meaning just about every molecule in the body is attached to some water. And water, as a vessel, it can hold information, and it can transmit information. And when what harms it is that when it becomes impure, because if you look at the water inside the cell, it behaves like a crystal. Basically it's like a crystal, like ice, okay, but yet it's liquid. So it's incredibly coherent, and that's because of the purity. So it's able to. So it's in a state where it's optimal if it has no impurities, if it has pure homogeneity within the water molecules, then they can hold more information, more energy. It's like looking at a river. One that has junk in it, you're not going to see to the bottom. But one that's clear and has nothing, you're going to be able to see all the way to the bottom, right? So where there is more space, there's more ability for light to come through, for ability for electrons and information. So everything is an information exchange that's happening in real time, and time that's much faster than we experience. And so now we're getting into really the molecular science of it and saying, okay, how does this machine work, and where are the and what why doesn't it work optimally, and how do you optimize it? And first thing you look at is water. And people, yeah, they walk around with a gallon of water. What they're doing is they're dehydrating themselves because it's the wrong water. Your body has to basically match the water that comes in osmolarity, in iso, in basically has to make it isotonic to the body. So that takes work. So you're constantly fighting against yourself. Like the body is like, it wants what it needs as a building block. And if you give it poor building blocks, then it'll be harder for it to disassemble and reassemble and then process out the waste as well. So you demineralize yourself by constantly drinking water. You're not listening to your autonomic cues that basically tell you when you're thirsty. You know, your brain, your body will tell you, hey, you're thirsty. So wait, I like to just drink when I'm thirsty. But also we recycle a certain amount of water per day. And I don't know what that is, like 30%, 35, 20, something like that. And then the rest, because we lose water, we have to replenish. So when I looked at it, I said, well, we should replenish ourselves with water that is closer in vibration to the water that our body has. So that way it's less work for the body. It's less taxing. Because there's a tax on everything. There's a carbon tax, right? you have to process out the carbon, right? So everything's got a benefit and a detriment, because there's always a carbon on the end of that, and that's the detriment. So you have to process out the waste, and you have to, if the body has to work optimally so that it doesn't accumulate the waste, as it efficiently is able to process out the waste faster than it's accumulating the waste, right? So, and that's an efficient system that's in harmony with the universe. Everything is just vibrating. I mean, water is kinetically dipolar. It's constantly vibrating. We're vibrating with everything. We're having gas exchange, oxygen, carbon dioxide. We're in this harmony with nature and ourselves. And when it's maintained properly, you're in a state of health. You're in a state of bliss, happiness, and you feel confident. Because health is confidence. You feel like you can do anything. And when you're not healthy, then you know, the smart person throws all the resources that they have in trying to get healthy. And for a long time, I wasn't. And so I threw all my mental resources in trying to understand what it takes and what it means to get healthy outside of like this dogma that we're taught. You know, like you have this, you know, it's deuterium depletion is really reductive compared to every other health intervention, because instead of putting something in, you're taking something out. So,
Yeah. So with the water, you hit on some of the things we don't need, toxins, or however we want to talk about that. So you have things like fluoride, microplastics, all kinds of chemicals, right? Just on and on and on about the different things that could be in there. So we can buy filters, right? We can buy different systems, distillers, reverse osmosis, sediment filters, whatever it is. Things like maybe Kangen. Like, can you go into a little bit of how you view, before we get into the deuterium depletion, the filtration processes?
filtration is incredibly important. I had a chemist friend that was looking to be somewhere, live away in the woods somewhere, and there was a small little Canadian town for sale, and he bought the town. And they warned him. They said, "Oh, everybody went crazy in that town. That place is haunted." And he's a chemist, and he goes, "Oh well, that's fine. I'm okay." And he tested the water; it had arsenic in it. These people went crazy because they had the arsenic, and he just put filters on it, and he had this, and he bought a little Main Street and the whole thing. But it wasn't that long ago, like I mentioned earlier, that we figured out that water needs to be filtered. Not all water is the same. In fact, you could drink amazing spring water that makes you feel good and you think is great, but it might have a little radiation in it. Like you don't know what's in there, right? You don't know. So for safety's sake, we figured the best water is filtered. And the first filtration that humans came up with, and I think it goes back thousands of years, is distillation. Right? We know that that's safe, right? Because water vapor comes up, everything else stays behind, and it condenses back as just as pure water as you can get, kind of like the rain. So that was the first level, and then membrane technology came in the 20th century, and they figured, well, we could do this much more efficiently just by running it through a membrane, and the membrane will strip everything off that molecule that is not water. Okay, and these were the standards of filtration: reverse osmosis, distillation, and then you have carbon block and all kinds of media filtration, right? And now you have some more interesting things: magnetic, vortex, ways to electrify media, impregnated silver nanoparticles, more advanced membrane technology, layered membrane technology. But it's still, you're separating everything that's not water from water. And then a new standard, this is a standard that we're promoting as a new standard of water purity, is that now we're going beyond stripping out all the contaminants or anything in water that's not water, and we're taking out a type of water from water. So it becomes infinitely more complex, and not something you can do at home, not something you can do with filtration technology. It is a type of distillation. It's just done under an industrial process, because you have a very small window of separating H2O from HDO. Like, they're not that different, but they have slight differences, and you exploit that slight difference in the phase change, and you're able to pull off the light water from the normal water. So, and that, unfortunately, that's done with a lot of power. That's what makes the water expensive, is you need an enormous amount of power, because at the end of the day, you're heating and cooling water to effect that separation, and you're doing it multiple times, and you're doing continuously, and you're doing it in equipment that takes a footprint of 40 feet tall and as big as you need wide, because how much supply you want to make. So you have one unit, and one unit produces a small amount per day. So it's just like solar panels. You keep multiplying those, and you have to keep, and the energy requirement is really the hardest thing. You have to have, if you wanted to make a lot of DDW, not only would you have a giant, essentially factory industrial footprint, but you would need and this is what we're attempting to do here now, is basically need a power plant. You need your own power plant. It's an energy game externally and internally. So we put a lot of energy to separate it, right? And that way it saves the energy of the body from separating it.
Yeah,
So
no,
we do it externally. Yeah.
it makes sense. It makes sense. So Victor, what are your thoughts on the whole alkaline water craze?
Uh, you know, yeah, not much. And the thing is,
Yeah.
the blood exists in there's a very tight window of pH, and anything outside of that, we're dead. So there is benefit to alkalizing the body slightly. I mean, we're talking tenths of a point. We're talking very minor swings. An increase in pH is an increase in inflammation. So it has to be measured and metered properly, because that's it's a way we fight infection, as we create inflammation and we create inflammation for healing injuries and things like this. But that has to be managed too, because there's side effects to the actual inflammation. So alkaline water, yes, slightly alkaline, fantastic. If you're drinking 8, 9, 10 pH, your body doesn't need that. It's nothing you find in nature. It's an extreme intervention, and the body likes things gently, I would say. Like this blue light craze, right? You don't wake up in the morning and all of a sudden it's noon and it's shining in your face. Everything is slowly. The birds come up first. You have the sunrise. It's beautiful, the dawn, and then everything's slow, and then it gets a slow up, slow down. Everything is just so magnificent, and we're in this world where it's like no, we're so industrialized compared to the way nature, the way we observe nature to work. Everything happens cyclically, and there's a if you exercise, you're not going to jump into exercising. You're going to warm up first, or you risk injuring yourself.
Right.
Same thing with everything. You have to build the resilience first, and then you can then you could set improvement.
Yeah.
So
No, it makes sense. I often say nature is the answer. It's always been the answer, and it's always going to be the answer. So, like, what can we learn? Why does nature do certain things this certain way, right? And so, like, something new to me that I think is absolutely fascinating is when you look at eggs, right? Eggs have a higher concentration of deuterium in the egg white. Why does nature do that, right? Which has led me down a bunch of rabbit trails that I think is absolutely fascinating. And there's a reason for it, right? So deuterium isn't just its negative connotation, right? Like if we wouldn't, Gabor literally said yesterday, we wouldn't be here without deuterium, right? So like I think it's so fascinating, but the way we have altered everything and the over exposure, the over accumulation of deuterium are massive, massive problem.
it's
So
about management.
yeah,
It's just management, right?
and Petra loves the term deuterium regulation, right?
Regulation.
Versus simply depletion. And so, will you go into some of the? I know we're not saying that light water cures cancer. That's not what we're saying. But what can you explain how you're seeing some practitioners or people utilizing deuterium depletion with
We're
with cancer?
we're seeing a lot of incredible stuff, and I tell everybody, I say, this it's not the water. The water is it just has one function, which we can quantify actually, and that's the reduction of deuterium in your body through the mechanism of hydrogen exchange. So that we can quantify, and that's why we have a lab that you can test your saliva or anything else within reason, and you can tell you the deuterium level before and after. So I just say, look, it's all you. It's the body's a self-healing organism. It's just what happens when you have not only affect the conservation of energy, but when you increase the amount of energy efficiency and the amount of electrons flowing through your metabolic pathways. When you basically not only basically free up the floodgates, so it's like the firefighters were battling the blaze in the Palisades, and then they realized there was no water. The firefighters show up, but the water wasn't there. So you have to. So it's the same. It's the same thing. We're basically giving you a chance. You're giving yourself a chance by reducing the deuterium in your body, so your energy pathways can work better, and that has some very surprising effects. Like the body just jumps in, and it's a metabolic intervention. As soon as you free up a little energy, the body just the cell healing ability of the body just steps in, and it's just it's phenomenal. It really is. I mean, just that little difference, and the whole Gabor. I love Gabor's work because he discovered something quite profound back when he was a doctoral student, in the 80s. He discovered that the ratio of hydrogen, of protium to deuterium, will determine if oncogenes turn on and off. And this is why I believe this is why we're essentially not banned, but highly censored on Wikipedia. Because every time somebody tries to put some serious information in there, it just gets removed and says, "Oh, this is snake oil." Okay, whatever. But this is real. He discovered this in the 80s, and he made it his life mission because because this hydrogen to protium to deuterium ratio determines so much, because we are really optimized for a level that's 20% lower than exists on the planet right now. Okay, and if you can get yourself to that, then you're metabolically optimized, or at least you're in parity with what is intended in the blueprint of the human species.
Yeah, absolutely fascinating. So there are different ways of measuring deuterium in the body, right? So like the breath, the saliva, blood. What are your thoughts about comparing and cross contrasting those different levels?
I think clinically it's fascinating because if you take most people don't need to go this far, but I think there are some clinical applications that are fascinating. So when I say go too far, um, you can test your saliva, you can test your breath vapor. Your breath vapor you test by collecting it in something and then getting a 2 or 3 milliliter sample condensed down to your breath vapor. And saliva is very indicative of your extracellular water, and breath vapor is indicative of intracellular water.
Hmm.
So you look at the delta, if there is a delta, and that's where you have some. That's where it gets interesting, because if you see a delta, let's say you have your breath vapor is lower than your saliva, then your body is working. It's metabolically efficient, and it's doing its best to limit the amount of deuterium that goes into metabolic pathways. And if you're seeing the same, then your body's not filtering deuterium at all. And if you're seeing that breath vapor is higher than saliva, then that's an indicator that you have a serious problem, a serious metabolic issue that is either manifesting symptoms or is about to. So yeah, there it becomes interesting to see the delta between the breath vapor and the saliva. I've never tested blood; it's just too messy, and I don't want to. I don't think it's necessary. So yeah, and there's a third way, which is you can tune an MRI, and Dr. Borosh is an expert on this. You can tune an MRI to see where the deuterium is in the body, because it's a stable isotope, right? And essentially it's a tracer. It's like doing a contrast, but you already have it in your body, and
Yeah.
you see where the deuterium concentrates, and it's very revealing. It concentrates in neoplastic tissue, tumors, cancer tissues, and places that require a lot of energy, the brain, the reproductive organs. So it's, we're just this, 60 years into it, we're still crawling into understanding this. But like I said, that big discovery that Dr. Logan made in 2007 really paved the path for deutenomics, because it made the pursuit of deutenomics legitimate, because there's no way to refute a mechanical problem.
Yeah.
It's what it is.
Yeah. It's absolutely fascinating. Yeah. I just I would love to just have some definitive answers on, blood or cerebral spinal fluid, or just to see like what the different concentrations are, and why the body's using them in the positive ways. I think that would be just absolutely fascinating as well. Um,
Interesting. Yeah. I mean, we know that fat has less deuterium than other like fat cells have less deuterium than other cells, and so. But yeah, the thing is, when you start on this path of deuterium depletion, it's really a intervention that is, really, I would call it the crown of biohacking, because you're doing something that doesn't exist in nature, essentially. I mean, it does, like I said, if you go in Antarctica and you start consuming water that's 89 ppm. By the way, I talked to some scientists early in the day, and they were telling me about how they spend what was it, 3 to 6 months in McMurdo Station down there, and they have all these spontaneous healings that happen down there. They were telling me about, like, people, like, some pain went away, some minor illness went away. Obviously, they wouldn't send anybody down there that is sick with anything, but like minor stuff. And then I was explaining to the scientists that, because they're drinking 89 ppm water, and they were just in shock. Nobody knew. Nobody even thought that had anything to do with it. But with deuterium depletion, we're making 10 ppm and 5 ppm water that doesn't exist anywhere on the planet. Period. So this is
right.
really a biohack that's founded in science, and we're just amplifying it because we want the quicker effect. We want to be able to deplete faster and maintain it longer, and then also use that as a way to be a little less strict on other things. We know keto is the way, right? We know that you produce more ATP on a keto or keto adapted diet. Well, the whole strategy of keto, the whole strategy of fasting, especially dry fasting, has everything to do with deuterium depletion. So we just go straight to deuterium depletion, and then we can have then we can be much more forgiving in other things because it's a top level intervention.
I love it, man. There's so many different. Bring up dry fasting. That to me is just absolutely fascinating. There's the diet, the sunlight, all of the different ways. I think that the natural ways of that we have built in for deuterium depletion and regulation are that's worth a conversation just focused on itself. So man, thank you for the time. As we wrap up, let's I look forward to continuing to work with y'all. Definitely, I don't think there's another really option to push people towards than Litewater. So, how do we best get this in front of people? And because as we're diving through the chaos here in Arkansas with we just got ivermectin over the counter,
That's
right?
great. It's fantastic.
Yeah, but oncologists don't want to hear it, right? So I can only imagine how they are with deuterium depletion. Like that's probably even a harder sell than ivermectin. So I
The
guess my
thing is,
point
most
is,
people, it's new to them, especially clinicians, but they become our best customers because they're smart enough to follow the science once you explain it to them. And
yeah,
once you explain it to them, they go, "Wow, how did I miss this?" Because it makes sense to somebody that has a science education, so they don't challenge it. They go, "Oh
well,
yeah, this is
if they objectively look at it, right? Like
yeah,
all the things. Because I remember sitting in after Lander was diagnosed. Like I said, what do I feed him? I'm like, well, it doesn't matter. I'm like, what do you mean it
yeah,
doesn't
right,
matter what he eats? Like that's the most crazy thing I've ever heard. But it's like to me, I'm glad there are practitioners out there that objectively look at it and apply it. But I still feel like this is a patient first approach on most things, right? Like
Well,
I think that
yeah, I think I have a different way. I have a different way of looking at it. I look at are you true to your form of medicine? And in the United States and most of the Western world, they practice allopathy, right? With osteopathy as well. But the definition of allopathy is to uh, induce injury to stimulate healing.
yeah.
That's all they do. They just create injury so your body heals. So they have no acumen in preventative medicine, zero. They do not know how to treat something until it actually is named. In that was that the Merck manual. You got like a million diseases. So preventative medicine, you don't have any. you just, you
Yeah.
just you, so they're deficient when it comes to preventative medicine and treating the root. They are symptomologists. They treat the symptoms and their mechanics. They're very good at what they do, which is allopathic medicine. They create injury to induce healing. And there's no injury. You're not creating an injury by drinking deuterium-depleted water. You're not creating an injury by eating good food. These are all preventative measures, and they're completely lost on
Yeah.
any making any recommendations or suggestions because that is not a formal topic of scholastic pursuit in medical colleges. That's why you have a robust secondary education industry for healthcare practitioners because they only get a foundation in allopathic medicine when they graduate from medical school. And there's so much more to learn when it comes to being a holistic, integrative physician. And the ones that are there, they will use all tools available. I mean, we're living in it's almost bankrupt. Our medical system is bankrupt. We call it healthcare. There's no healthcare. It's actually sick non-care. And but yet at the same time, we have the best emergency medicine in the history of humanity. It's incredible. So you go to the specialist that focuses on the specialty that you need. So if you need allopathy, you go to allopathic medicine. Unfortunately, a neoplastic condition, cancer, is not well treated by allopathic medicine. Sorry, it's not.
Yeah, the numbers, the data doesn't lie. Yeah, I worked EMS about 8 years. Like I have seen the miracles of acute care, right? Of
Incredible,
trauma care. It's
incredible.
absolutely
It's just, I mean,
amazing.
unbelievable. You can't even. It's almost science
Yeah,
fiction how good it is.
yeah, yeah. And then you have. That's why I respect Petra so much. Like she is as integrative, I think, as you can get. She's doing amazing things, and it shows, right, with the results. And so, but at the same time, like Victor, you and I wouldn't have this conversation if I wouldn't have searched out things, right? Nobody's ever told me about this. Nobody came to me and said, "Hey, you should check out deuterium depleted strategies." Like I ain't right, and I don't know how I would have received that either. But it was the self searching, just trying to find answers that brought us here. So I think that there's still going to be so many people that can benefit, as long as we just get the message out to them, and they we build trust, and we don't have snake oil salesmen and promises of something else, right? Like that it's not. And this is, I think we've laid out a really really good way of looking at this holistically. And again, man, I thank you for taking the time to help us do that. I look forward to trying to get Litewater and in front of everybody through the store, and just exposure with conversations and content. So again, thanks, man.
And if I thank you, appreciate that. And if people don't have light water, it doesn't mean that doesn't mean that they shouldn't understand what's happening in the body with heavy hydrogen and how to keep it down. We live in a modern society where we overemphasize carbs in the diet, and that artificially elevates deuterium levels. So it's just it's like eat less, you know, drink less, even, because like we were talked about, we overconsume food, we overconsume water, and we overbreathe. Actually, we're chronic overbreathers as far as as a species is concerned. And you look at the epidemics and the chronic conditions that we have, and they're all rooted in the wrong diet, exposure to toxins, not breathing right, not drinking everything. And what's sad is we hundreds of years ago, when we were like fully analog, we had it figured out. And if you haven't it, you just need more integrative approach.
Yeah.
Because you
We
just
do
take
all that and then hide from the sun, right?
and then hide from the sun.
It's
Yeah.
craziness. It really is. But
An
again,
integrative approach is uses everything that you have available to you. It's just intelligent. Just intelligence takes over and tells you how to use it without hurting yourself. You could use the drugs, you could use the pharmaceuticals, you could use the trauma care, use the sun, you can use light water, but to have the intelligence to know when and where and how is something that we have to. It's hard to find someone to rely on. At least for me, it's been very hard. I've had to rely generally on myself, because the information that I found is incomplete, and the practitioners were less than ideally informed, let's just say. So cultivate a sense of inquisitiveness. I think that's the best thing, because then you'll find your own answers. They're out there. I mean, we live in this incredible world where everything is at our fingertips if you know how to ask a question properly. So otherwise, you'll just be told, right? If you can't manage yourself, someone's going to start managing you. So it's time we take that. Sometimes we take health into our own hands. I was like your son and your family. I was doctors failed me. Okay, I said, okay, I have no recourse. I have no one else to turn to. Who am I going to turn to? Is there a shaman? Because these doctors can't help me. So who's left? I guess I got just me then. Oh, okay. Well, all right. It's fine. It's fine. Me and my ability to research and understand, and then everything that's available to me, right? It's still, everything is there in the world for you. You just have to know how to use it. And if it's so, yeah, it takes that kind of that moxie. You got to take it and take the responsibility for yourself and say, I'm gonna work with myself as my doctor, and I'm gonna use these other people as guides, and I'm gonna throw opinions off of them. But ultimately, I'll be the decision maker, like that mobster in Chicago. It says, "Oh, you want to diagnose me with cancer? That just means I need more sun. Thanks."
I love that. I love that. That's one of my favorite takeaways ever. So thank you for sharing that,
Yeah, you're
Victor.
welcome.
I'm excited about the future, brother. I'm excited about working together and the conferences y'all put together, bringing water researchers. That's huge. That's so cool. And so uh, again, thank you for the time, and we'll keep trucking along.
Thank you. Appreciate it.